All right, so today we're going to finish chapter 17, which is still sampling distributions. However, we are now going to be doing sampling distributions for proportions. So what we did last week was the sampling distribution of means, because all the examples that we did was like the mean weight or the average score, or I don't know what other example we did, but it was means. Today we're going to do sampling distributions of proportions. So the first vocabulary word you need to know, see if you know it, fill in the blank here. The blank of a statistic is the distribution of values taken by the statistic in all possible samples of the same size from the same population. I gave you that definition last week. So if you remember it, fill it in. If not, here it goes. It's called the sampling distribution. The sampling distribution. So remember that you do need, remember that you do need to recognize that definition. So one more time. The sampling distribution of a statistic is the distribution of values taken by the statistic in all possible samples of the same size from the same population. So that was last week's definition. Here it is again. Here's the new thing for proportions. The sampling distribution for a proportion, provided that the samples are independent and that the sample size is large enough, has these formulas. Here they go. I guess you just need to write down the formulas. The mean of the p hat equals p. I'll explain to you what the symbols mean. For now, write them down. And the standard deviation of the p hat equals the square root of p times 1 minus p divided by the sample size. So basically, here's what these formulas are. You need to write them down and memorize them. So today we're going to be doing finding probabilities with like your normal CDF. And since it's proportions, what we're going to use for the mean on today's examples is going to equal to the proportion that is given in the problem. Like it's going to tell you the proportion of females or the proportion of Hispanic students or whatever. So the mean that we're going to use on our normal CDF is going to equal to whatever proportion is given in the problem. The standard deviation for our normal CDF calculations is for today is going to equal to this stuff, the square root of p times 1 minus p over n. And we'll do an example in a minute. Just like last week, we do need to check some conditions. The good news is that they're pretty much the same thing as last week. So let's write them down. You can read that by yourself. I'm just going to start reading here conditions. We're going to check these conditions in order for us to actually do the math. So number one is called the randomization condition. It is the exact same thing as last week. Randomization condition. So the problem needs to say we have a random sample, or we can just say assume we have a random sample of students or whatever, of blank. So assume we have a random sample of, and then blank. Second thing is still the same, 10% condition, 10% condition. So either we know for sure that our sample is less than 10% of the population, or if we don't know for sure, we can just say assume our sample is less than 10% of the population. And then, okay, finally, remember the large enough condition, the third one? Okay, for proportions, it's called something slightly different. It's called the success/failure, but you can still call it large enough if you prefer. Large enough condition. This is the only one that's different, and this is where students get confused. So for last week, when we were doing means instead of proportions, when we were doing means, I just told you what the large enough condition was. Either the problem says normally distributed, so for the means, or you have a sample of at least 30. So that's for means. However, here's what it is for proportions. So for proportions, in order for your sample to be large enough, here's where you check. You're going to check that n times p has to be greater than or equal to 10. And n times 1 minus p has to be greater than or equal to 10. So that's how we check the large enough condition for proportions, and that's because statisticians have already spent like years determining this, so we're just going to go with it. The textbook has an illustration of why it works, so if you care, go look at the textbook. Or I think my PowerPoint in Schoology has an illustration of why it has to be at least 10, but if you just go with it, then that's fine. So in conclusion, the conditions are the same as last week when we were doing means, except for the last one, the large enough. We're just going to be checking this n times p is at least 10, and the n times 1 minus p is also at least 10. So let's do the first example, which deals with this large enough condition before we move on to a real problem. So check this one out. Number one. Number one is called a proportion because it's giving you literally like a percentage right there. It says, it is estimated that 62% of motorists use their seatbelts. I don't know why, but only 62. What is the smallest value of n? So like, what's the smallest sample size for which you can use the normal model? So basically, it's asking you to find the smallest, or it's asking you to find like the smallest sample where it would be large enough. So let me just write it down. Find the, I guess, smallest sample size, and that would be large enough. That would be large enough for the normal model. For the normal model. Okay, so here's what you're going to do. You're going to use that third condition that I just gave you. So do some math and figure out if only 62% of the motorists use seat belts. So that means that if P equals to 0.62, so if our proportion is equal to 0.62, I need you guys to find me the smallest sample size n that would be considered large enough. And your hint is, in order for it to be large enough, n times p has to be at least 10, and the complement, n times 1 minus p, has to be at least 10. So let me give you a minute to do some math. All right, so basically you're just doing some algebra now, and you're trying to figure out n times p has to be at least 10, and n times 1 minus p has to be at least 10. So therefore, I'm trying to figure out what is n if p is 0.62. So just divide that. 10 divided by 0.62 would be, n has to be at least, like, I got 16.13. However, you still have to do the other one here. Okay, thank you. You have to do the other one here. So this is going to have to be n times, what's the complement of 0.62.38? It's at least 10. So then n has to be at least, let's see, 26.3. Okay, for the final answer, you have to, I guess, common sense, think about it. You can't give me 16, because if n is only 16, then it's not going to work over here when you do 16 times 0.38. So you have to go with the larger one here, 26.3. And then in terms of, I guess, common sense, you can't really sample like 26.3 people or 26.3. So we're going to have to go with at least 24. At least 24. So round up. So basically just me this.
Wasn't that 27?
Oh, I can't do math. And I'm glad y'all said something. So if you're watching the video, just ignore it. All right. At least 27. Where did 24 come from? Maybe if you, I have no idea. Anyway, thanks. So at least 27. So that means that if your sample is at least 27 here, then this will be large enough because it will meet the n times p and the n times 1 minus p to be at least 10. So that's how you check the large enough condition for proportions. So pause for questions before. So now let's do like a full-on sampling distribution problem. Here they go. Number 2. Suppose that 30% of students at CHS wear contacts. I definitely think it's higher than that. But in a random sample of 100 students, what is the probability that more than 35% of them were contacts? So this is what's called a proportion, because it says 30% of students were contacts, versus like if you had like their height or their weight or their SAT score, those would have been means. This one is called a proportion. So, proportion. Let's check the conditions. I already told you at the top there, the conditions are randomization condition, randomization condition. So, your quiz, your chapter 17 quiz, I'll let you know more about it, but it's going to be today in the AP classroom, and that one's all multiple choice, so you don't have to write anything down. Your test, the one free response question, remember that you will have to, I guess, type up the conditions because the test will be in Schoology, and this will be like the free response. So number one, randomization condition. I think the problem says we have a random sample. So problem says we have a random sample of students. Don't forget to be specific or you get points off. So make sure you put off what. So number one, done. Number two is called a 10% condition. If you're not sure about the population of students at CHS, then you can put assume 100 students is less than 10% of the population. I know we have like 2,500 students or so, so I'm just going to put surely 100 is less than 10% of population of students at CHS. But again, the first two conditions, if you're not sure, then you can just put assume, and that would be totally okay. The only one really that needs to be checked is the large enough. I like to call it large enough condition, even though it's supposed to be the success/failure. Either one's the same. Large enough condition. Okay, so here's where students get confused, like on the test and quizzes. They'll start saying like, oh, since 100 is greater than or equal to 30, the sample is large enough. And that's not what you use, because this is not a mean. Like it's not, these conditions don't apply. These are the means. So the central limit theorem doesn't apply to proportions. It only applies to the means. So for the large enough, remember, we just got to check n times p has to be at least 10. And then times 1 minus p has to be at least 10. So just show some work. What's n? 100? What's p? Oh, and here, let me help you determine what's p. So, n is the sample size, which is 100. Okay, now we need to determine the difference between p and p hat. And I think I forgot to say it at the top. And I'll say it now. P should be the parameter. So this is called like the proportion of the entire population. So let me write it down. So this P is the parameter, which is the proportion for, oh, it's not going to fit, for the entire population. For entire population. So anytime you see like P would be the proportion for the entire population. Now when you see P hat, I guess I'm going to put it over here because I don't have room. P hat, that's a statistic, which means that's the proportion for sample only, for a sample only. So I need you to, I guess, read number 2 and determine, you have a 30% and you have a 35%. Determine which one is representing the proportion of contacts in the entire population and which one is representing the proportion of contacts in your sample. So read it again. Suppose that 30% of the students at CHS were contacts, so that sounds like a population. if you select a sample of 100 students, what's the probability that 35% of those were contacts? So the 30% here should be for the entire population. So this is going to be P equals 0.3. Versus you're looking for what are the chances that 35% of your 100 students in your sample were contacts. So that's going to be your P hat. So for the specific sample. Okay, so now back to the third condition. Let's finish checking it. When you're using the third condition, notice how you're using N times P and not the P hat. So we're not going to be using the 0.35. We're going to just be using the P, which is 0.3. So let's check to see if 100 times 0.3 is at least 10. It is, because that's 30. And then let's check to see that 100 times 0.7 is at least 10. And yes, it is. So let me pause for questions on the conditions. We checked all the conditions. We can actually do the math because it looks like all the conditions are checked. So to do the math, the question wants to know, what is the probability that more than 35% of your sample were contacts? So I guess here's how I would write it. I would look for what is the probability that my P hat is more than 35%. And again, I'm using the P hat because you're interested in knowing what is the probability that more than 35% of the 100 students that you selected is wearing contacts. So we're doing this P hat, so that applies to my sample only, is more than 0.35. And here's how you do it. We're still doing normal CDFs. Normal CDF. And you're going to put the lower bound, the upper bound, the mean, and the standard deviation. So I don't think it's going to fit on here, but here's how you would do it. The lower bound, since you want greater than 0.35, the lower bound should be 0.35. Again, since we want greater than 0.35, the upper bound should be infinity. And now here comes the tricky part. For the mean and for the standard deviation, you have to use the formulas I gave you at the very beginning of the notes. So let me remind you. The mean for proportions is always equal to the population proportion, P. So mean for proportions, it always equals to the population proportion. Population proportion. And then the standard deviation of proportions, it always equals to this big formula. So let's actually use it. Let's find the mean. So the mean for this proportion should equal to whatever the population proportion is. So right here for the mean, I'm going to use the population proportion, which was 0.3. Remember that 30% of all students were contacts, so that's my population proportion, 0.3. And then the standard deviation is going to be that big formula that's at the top. And so it doesn't fit here, so let me just put it right there. It's going to be the square root of 0.3 times 1 minus 0.3, so 0.7, divided by the square root of the sample size, divided by n. And this entire 100. This entire thing is under a square root. So let me show you how to type it into the calculator. And this is how you type it into the calculator. You go to Scratchpad. You go to menu probability. Just like we did last week, menu 5.5. We're still doing normal CDFs. And then I just told you the lower bound is 0.35. The upper bound is infinity. And then again, we're doing this without z-score, so we actually need to type in the mean, which was the true population proportion, and we need to type in the standard deviation, which is the square root of 0.3 times 0.7 divided by 100. Just type it in like that. And press OK. And that should give us an answer, which just double check with the answer keys. Yep, that looks right. So that is the chances that in a sample of 100 CHS students, 35% or more of them are wearing contacts. So let me put that over here. 0.138. I guess I can round. So let me pause for questions. Pause for questions.